Hi everyone and welcome to our dev call. And today most of our agenda will be presented in the version of slides. So Maxim, go ahead.
Hi everybody. Today the call will be devoted mostly for reviewing the release that is happening during this week. We are releasing a new version of the libraries and SDKs that we are working on. This version is named 0.3. It's the third release so far. I will be covering the changes in this release, and also I will cover the issues, the pending issues, which we need some help on. There are two issues which we would like to discuss and ask community for provide its assistance. Also, I will be paying some attention to the further roadmap and will cover the structure, the current structure of all libraries and their interrelation and how the functionality split between them and how the developers can integrate with them from different perspectives. So to simplify for all developers joining RGB, because today we have a lot of repositories, a lot of libraries, and people need to understand where to look for what. So this will be also covered during the presentation. And at the very end, I will have a slide from a contributor who joined RGB community in Telegram today, and he shared his understanding of RGB workflow in the form of schema, which is quite good. I will just quickly comment a few small issues with it, like how it can be improved even further, but generally I also would like to invite everybody who would like to understand RGB and how to use it to look into this workflow. So let's start. The version 0.3 release for the most of the libraries referenced here, it's already released to the public repository in Kratos.io, where all Rust libraries are usually released. What happened during the last months of its development and what's new with this version? Our original roadmap for version 0.3 was a bit different from what we actually achieved, and the main reason for that was the update, the very large update from Bitcoin and Miniscript, which happened last week, and we was waiting for it for about 2 months at least. And while Bitcoin 0.226 includes a lot of PRs that we've made from the functionality that we need and from the code that we had before in the LNPBP core library, it was backported to Bitcoin. So this was an important update for us. It also brought a lot of changes, which are not related to what we are doing. However, the changes are API breaking. And it's even worse with Miniscript 5.0 because the previous version was based on Miniscript 3.0, our version of our libraries and all the nodes. And then there was a 4.0 breaking API, we upgraded to it, and then 5.0, which another time broke an API. So we witnessed many issues. And this actually resulted in the fact that we had to do a big refactoring of the whole library. My original plans was to do the refactoring of the library much later, when we will have a first software working at least. This refactoring doesn't affect the API that wallets are integrated with. It doesn't affect RGB SDK and the future LNP SDK. This is internal refactoring. Unfortunately, because of this release and the need to use this new versions of Bitcoin and Miniscript, we had to do this refactoring right now when it wasn't critical otherwise. However, that's actually why we're releasing version 0.3 now, to be able to turn this page and continue building on the stable version updated to the latest Bitcoin and miniscript developments. So what's new in the release? First of all, and what was done with the refactoring? We have extracted and the library, LNPBP core library that we have, which has all the business logic and functionality of RGB, Lightning Network, a lot of Bitcoin related stuff. It grew really large. And it was the main dependency used by the nodes, by RGB node, LNP node. The compile times was very high. The library size was big. There was a lot of version dependency issues when, for instance, because the library was dependent on a lot of other Croatescent libraries, and when one of those libraries updated, we've witnessed a lot of version conflicts with other unupdated versions of our dependencies and so on and so forth. So the decision was to split this big one huge library into a set of libraries and split them across the repositories as well. So first of all, we had extracted 4 main components. The first component is RGB. We called it RGB core. The whole code implementing RGB data structure, primitives, validation, everything related to RGB is extracted in a separate library called RGB core. RGB node depends on this library, and the difference between the node and the library is that the node is actually, it wraps RGB functionality into daemons, processes, it works with networking, it works with the storage, but it has nothing to do with RGB business logic or validation. Everything that is business logic and validation are kept in RGB core library. This also gives an ability for us to create a software which wouldn't depend on RGB node because it's another complex project, but would be able to use some of RGB primitives, for instance, creating invoices or analyzing a single RGB state transition or parsing a schema or genesis, understanding its structure without keeping client validated data. Now this all can be done by software like block explorers or something like that without the need to integrate RGB node. The same thing was done for Lightning Network specific code. So it was extracted into LNP core library, and LNP node will depend on this library. Again, the difference between the node and the library is the same like for RGB. So all business logic, all Lightning Network specific stuff is kept inside the LNP core library, while node adds networking interfaces and the rest into this equation. The third library which we extracted, we called it Internet2. And I've been talking about this concept of Internet2 a few calls ago. The idea is that inside the Lightning Network, there is a lot of primitives for peer-to-peer networking, which are very useful for generic software development, and which has nothing to do with the Bitcoin and Lightning Network itself. Starting from noise HK encryption mechanism and up to the encoding formats for the messages and so on. So we have taken these parts aside, we joined them with a Tor related code, and we made an ability of building not just peer-to-peer, but also RPC interfaces, and we linked it with a zero message queue, and we're using it everywhere across the nodes that we are developing. So it's used by nodes, and we call this library Internet2 because this is a way of building a decentralized software without dependency on decentralized parts of Internet like centralized DNS services or SSL encryption and everything like that in a Lightning Network style, but without the payments and everything else which is added on top of that by LNP core. The fourth library which we extracted is Bitcoin descriptor wallet library. Basically, this library contains everything that is generic to Bitcoin. It has nothing to do with the Lightning Network or RGB. It's just the stuff that is absent from the current days Rust Bitcoin libraries, from Bitcoin development kit and from Rust Bitcoin and from Rust miniscript, but which is important and required for creating wallets, for doing signatures, working with PSBDs, and so on and so forth. So we put it aside as a separate library, and this library, with the time, we will work on backporting this functionality into Rust Bitcoin and Rust miniscript. I've got acknowledge from Andrew Pelstra, who is managing the Rust Bitcoin project, on conceptually accepting these parts in the future. So we will be working on backporting most of this library. So it's a temporary library, which is an add-on to what Rust Bitcoin and Rust miniscript provides. Another important note regarding the Rust Bitcoin, we actually being a very large contributors to Rust Bitcoin. We're counting for number 3 in its development. And this week I became a maintainer of Rust Bitcoin repository with a merge right. It wouldn't help us to backport what we did because I can't merge my own PRs. I can only merge others' PRs. That's how GitHub is working. But anyway, that's quite an important milestone for everything that we was doing. And just important to see that we are not just developing RGB, we are contributing a lot into the core Bitcoin projects and Lightning projects. The rest of the library, so we still have LNPBP core library. It is split into multiple sub-libraries, so they all reside in the same repository, but they cover different aspects of functionality. So this is the main part of the release, which is refactoring of the library into multiple core-tested libraries. Functionally wise, in this release, we added Lightning-specific message encodings. This opens us a way for making LNP node interoperable with other Lightning nodes for Bitcoin transactions, of course. So for Bitcoin payments and Bitcoin channels, Lightning LNP node is scheduled to be interoperable with LND and with the C Lightning in a release or two. And this change, the Lightning-specific encoding, actually is the main part which is required for achieving such interoperability. We added Raj, our contributor. He added bolt 7 message support for Gossip protocol to the LNP core. We refactored the unified network address formatted encodings. It's not important change, but it's just some of internals. And we refactored deterministic Bitcoin commitments. So that's what was in this release. A few notes on the further roadmap, which is we plan to have the version 0.4 in March. Around March. The core concept with this version will be completing Lightning Network support and Lightning Network related stuff. So we plan to have the universal invoices, which we was discussing 2 calls ago. These invoices allow you to create RGB on-chain, Lightning Network Bitcoin, and Lightning Network RGB payments and invoices with a single format. It will contain Lightning Network routing and Gossip protocol, so it will be able to interoperate with other Lightning node implementations and do multi-hop payments and the rest. So that's big plans for the next release. And the 5th release, version 0.5, will probably happen in May, 2 months after the next release, and that release will be focused on infrastructure. The preliminary plans that we will have an initial Bifrost protocol added to the LNP node, and this Bifrost protocol will enable such things as storing. It will be a part of RGB infrastructure, providing network with ability to publish information about assets, to publish information about schema. It will also work as a form of watchtower for RGB when the mobile wallet is offline. And I will be showing at the end of the presentation how actually we plan to set up mobile wallets with a Lightning Network and RGB, how we can solve the problem of requirement of being constantly online, and Bifrost is a part of that equation. And later on, we will be adding to Bifrost protocol features required for running decentralized exchange functionality of the Lightning Network with RGB assets. Additionally to Bifrost protocol, we plan to add more privacy and encryption, complete source support, update and refactor BP node, which is the indexing node, with an aim to replace Electrum server with a more functional and fast analog. So it will be mostly around infrastructure. We also have a pending work on non-fungible assets, implementation of the specification that we was discussing before the new year. I haven't assigned it to specific release yet. It will more depend on how the development of other functionality will go. There are also two pending issues. Before getting to that, probably I will ask for any comments or questions regarding this part. Maybe you have some of them.
Well, I have a comment, probably in addition to the NFT related part. I have been in talks with at least 4 different people and companies that are very interested into moving forward with the NFT topic. It does not mean that we're shifting, as Maxim said, that we're shifting our priorities right now, but the demand and the interest is very high, actually amazingly high. So I think that at some point we will need to add that to our roadmap and to probably reprioritize some stuff, but obviously not now.
Yeah, I understand that, and that's a hard question because the Lightning Network is clearly a priority. So I'm not sure that we will be able to complete the non-fungible assets till the end of March. There is a chance, so we will continue working, but I just don't want to promise what I think that we hard to deliver in this regard. But anyway, again, if we will have somebody joining us and contributing, that will be a big help, because we are very few hands and very limited in our resources currently, so we have a small through output. Sorry, I'm jumping because I mixed the order of slides. Basically, I covered this slide. It recaps why we needed a refactoring. That's large-scale refactoring. Especially, what I forgot to say is that it's very important to align the repository structure and library structure with the requirements for peer review and merge criteria, because the mission criticality of different libraries is very different. And there are libraries which are highly critical in terms of security entity of RGB funds, which has to be carefully reviewed, and the other libraries which are just simply utilitarian and they don't affect anyhow the risk of fund loss or key management or anything like that. So with this refactoring, we clearly separated these parts between themselves, and this will simplify the peer review process. And there will be a slide where I will be covering which parts of the library need a more careful peer review. The current issues that are pending and which we are asking community help for and the opinion are these two. The first one was found in RGB SDK yesterday, and something prevents the library, the RGB node library, binary library, embedded into Android mobile applications to be linked to the Android application itself. So this wasn't happening before. So this library was clearly linking and we was able to use it from Android application without any issues, at least in the mid of December. However, something changed after that. It's not clear what changed, what has changed. I did some investigation yesterday, and the problem is that it's not in the code. Android just don't see this library. The binary library is there, but Android says that it lacks some symbols and link the library to the application itself. So it happens before the application starts, before any function is called. So it's operating system level issue, replicating on both mobile devices and simulators and different computers. And it's really not clear why this may happen, because the symbols are clearly there, and we try different ways of fixing that. It's all described in the GitHub issue on this link. So we ask everybody who has an experience with a native development kit for NDK for Android to look into it and maybe suggest what is the reason and how it can be fixed. The second issue, which is related to the actual specification of RGB itself, and we found it out occasionally because of this refactoring that we was doing. I used this opportunity of refactoring to carefully check each piece of the code to review it, self-review it, and we found that with Miniscript, there is we used Miniscript for modifying transaction output scripts with the tweaked keys. And the fact is that Miniscript doesn't allow you to do a round-trip compilation. So if you take a script, convert it into Miniscript, and convert back to the script, to Bitcoin script, you, with a high probability, will get the other script, which is different from the initial one. And when we are using Miniscript in script modification, we're actually modifying the script structure, not only tweaking the public keys. This is the issue for legacy scripts created before Miniscript invention. And the main problem that Lightning Network is actually composed of such scripts. So Lightning Network scripts, they are not Miniscript compatible. And in practice, this issue means that when we use RGB inside Lightning Network with the current code that we have, we modify the script from being standard. This is not a large issue because anyway, you wouldn't be able to use RGB inside Lightning without other nodes using the same code and using the RGB inside Lightning. So it doesn't breaks interoperability. In fact, it's more like the actual transactions from the channel will be different from the Lightning Network standard, which I'm not certain that it is bad in this case. So we have basically three options about which I would like to ask the opinion. So first of all, we can leave it as is and basically say that RGB upgrades Lightning Network transaction scripts to Miniscript compatible level, which is probably a good feature, and it may happen anyway with L2 or even earlier than that with a specific feature flag. So that's the first option, and actually it's default option as it is today. We just discovered that this is the fact. We didn't know that, but now we have discovered that. The other option is to change our standard LNPBP2 and use Miniscript for deterministic detection of the keys inside the script, but don't use Miniscript for script recompilation and manually change this inside the script after they were located with Miniscript. And the third option is basically don't use Miniscript at all and develop our own code and standard how the public keys can be detected inside the arbitrary script and tweaked. So these are three options, and I would like to hear your opinion on them.
Not easy decision.
But was I quite clear in explaining what is the reason for the issue, or we need more details?
It is clear, at least to me.
Mm-hmm. Well, again, we are not required to take decision right now. This issue doesn't affect, in fact, anything other than the clearness of the specifications, and like we would like the code to work according to certain specification. And here we have a small disconnection with Bolt 3 standard.
Maxim, what would be the main con of the first option? So upgrade RGB Lightning Network to the miniscript scripts. It will be just like more time intensive and stuff like that.
No, it's the situation that we already have today.
Oh yeah, it's a less time incentive. Yeah, okay, right.
It's less time incentive, but like the only thing against this decision is that when LND or C Lightning, for instance, would like to add RGB, they will see that RGB will require them to use miniscript, and today they are not using miniscript.
Okay, so this makes compatibility between RGB enabled Lightning Network node and an existing Lightning Network nodes harder, and it will increase the difference between the way an RGB Lightning Network node works and normal Lightning Network nodes.
It wouldn't decrease the compatibility between RGB and normal Lightning network. No, it wouldn't. It would increase the complexity for other existing nodes to integrate RGB into their code base.
Yes, okay, thanks.
Well, actually not, because it's used inside the RGB library and they will be integrating with RGB library. So we did it for them. And probably yes, it wouldn't make it harder for them, but they may be unhappy due to some political or other issues. I
was thinking the probability of existent Lightning Network implementation to adopt RGB outside the library that you're creating is anyway quite low at the moment, right?
I would say that it's very not recommended, because you need to spend at least a year writing everything from scratch. Like you need to implement all RGB, which is I doubt that anyone will do, and it will open a lot of security issues.
Yeah, instinctively the first solution seems more rational, considering that probably no implementation will adopt RGB outside the scope of our libraries. But the only possible cons that I see is that miniscript itself is proving to be still a little bit unstable with the recent changes. So that's the only caution that I would feel. But otherwise, I think the first solution would be probably better.
There are two different things regarding miniscript. Miniscript as a standard, which is more or less mid-mature, I would say, and implementation of miniscript standard in Rust library by Andrew Pylstra. And what changed is not the standard, but the API of the implementation, which doesn't affect how miniscript actually works. But I just don't know the general policy of Lightning developers today compared towards miniscript, because there are chances that they would like to adopt it anyway, for instance, or otherwise they would oppose of any use of miniscript inside Lightning Network. I don't know for which reason, so I just don't know how what's their position regarding this fact. The problem with the second and the third point is that it's, I would say, security critical, because if we will go this way, we will need to make sure that we are designing an algorithm which will be safe. So right now we are relying on the safety of miniscript designed by Peter Will and Andrew Pylstra, which is was peer reviewed, being in the development for at least a year, and we don't have a headache of making sure that we cover all edge cases and everything like that. If we will avoid use of miniscript or a tweak procedure, then we will have to develop something of the same level of determinism, which would be it's not hard, but it's hard to make sure that you're covering everything, all edge cases and everything. So adding another complexity to the standards that we have, which is, I think, is not a good thing.
Yeah.
Federico is probably not on the call today. I will also ask his opinion because he was involved into the decision process on LNPBP 2 standard as well. So let's have a discussion on GitHub, and we have a time, so it's not needed for take a decision right now. So at least have at least months before the deadline of deciding how it will work. And even after, it can be changed because it's a part of, not RGB, it's part of Lightning Network. And yeah. Okay, let's move forward. So one slide where I would like to cover the difference between Bitcoin-related functionality, how it's currently split between LNPBP core library and this new wallet descriptors library or descriptor wallet library. The idea is very much simple. Everything that is related and covered by LNPBP standards, even those parts which are not directly RGB specific, is done inside LNPBP core library. So there we have all the deterministic Bitcoin commitments with miniscript, which we just discussed, and the rest of public key tweaking procedures and all of that. Then there we have a Bitcoin single-use seals, primitives, and Bitcoin blended UTXO data structures for creating RGB invoices. We have a short Bitcoin ID for reducing the size of Bitcoin indexes. We have chain parameters that allow us to abstract from specific Bitcoin blockchain we are using, so we can work on Bitcoin, Liquid, or different test nets, or federated chains, even custom ones. We have target hash extensions and an LGAML encryption with Bitcoin keys, which is not even used inside the RGB, but it is a part of LNPBP standards. In the wallet descriptor library, I moved everything that is generic for Bitcoin and covered by other existing standards, BAP standards, sleeps, or just utilitarian functions around those standards. So in the descriptors library, we have a extended script typing system that allows you to differentiate scripts from different parts of the transaction. Like you will always have a different type for redeem script or script pub key, and you have conversions between them. We have a lot of extensions for descriptors. In particular, the current Rust implementation of descriptors, it works only with miniscript. Whenever you will need to do a descriptors for Lightning Network, normal Lightning Network, not RGB, you wouldn't be able to do that with the existing descriptors. So I had to develop the descriptor type system on top of both miniscript and Bitcoin that allows to work with both legacy Bitcoin scripts and miniscripts. BIP32 extensions for dealing with the situations when the private keys are not available, and being able to derive all the necessary keys even without direct availability of the private key. Sleep 132 extension that allows to import and export to interoperability with Electrum and hardware wallets, which use this YPub, XPub, ZPub format. Hash lock contracts, types related for working with hash lock contracts, extensions to partially signed Bitcoin transaction format, functions for lexicographic reordering of transaction input and outputs, and keys inside the multi-sigs, both in the transaction itself and in partially signed Bitcoin transactions, and feature flags, which are currently used in the Lightning Network, but also used in RGB and probably will be used in other software. Feature flags is not actually covered. It's covered by Bolt standard of the Lightning Network. So that's the core idea. So when you will be working and looking into descriptor wallet library, you will see basically everything that is needed for Bitcoin wallet, Lightning wallet. It has nothing to do with RGB. Most of it will be, with the time, backported to Rust Bitcoin and Rust Miniscript. And it's also hosted under LNPBP GitHub repository. While whenever you would like to use something of LNPBP standards, you will need to look into LNPBP core library. That's the idea behind that. I covered this slide already. Yeah, I'm not reading anything. To help those who are working with the libraries and products by LNPBP Standards Association, I have this small explanatory slide that sets the difference between different products and libraries we are doing. So we have, as LNPBP Standards Association, we produce two things: products and libraries. The products are either standards, it's a product for expert community, or a piece of software that can be compiled and run on some device, or an SDK that can be used by developers who are developing end-user consumer-facing software like wallets or doing exchange development, and they need to integrate RGB or Lightning Network into their products. So these are products that we are developing, and for standards, we have LNPBP standards, which are partially written today. We will be completing them after the release of the first software working with RGB, but it will be very important for others to review and understand how RGB works and make sure that everything is interoperable. And we will be also writing an RGB specification in form of semi-scientific yellow paper that will explain the technology behind RGB, because standards, they are separated and it's hard to guess and grasp how the overall RGB system is working. So there will be a separate specification on RGB. In terms of software, what we have are the nodes, the RGB node, which as a reference RGB node, and the reference RGB implementation node implementing RGB, and LNP node, Lightning Network node, another Lightning Network node that allows experimentation and that supports RGB from day one, and BP node, which is today outdated, but as I said, we have a roadmap for improving it. It's a node indexing Bitcoin blockchain, so it actually provides an alternative to Electrum server. It has more compact index. It allows you to work with a descriptor-based queries, which is important for descriptor-based wallets, and potentially it will be also contain libBitcoin consensus library from Bitcoin Core, so it may become a full validated node at some point, written in pure Rust. And the SDKs. We have the main SDK today is RGB SDK for integrating RGB into the wallets and for exchanges. And we're developing LNP SDK, the same SDK for integrating LNP node. The difference between the node and the SDK, that SDK allows you to link and use RGB and LNP from other languages, from JavaScript, Python, Java, Swift, C, and so on and so forth. And it provides a tool set and class libraries around that, which are language specific. In terms of libraries, we have three categories of libraries, and libraries will be interested only for those who would like to contribute into RGB development or LNP development, or build some really low-level experiments with them, or integrate their software at low level. So the products are more interested for consumers, for instance, somebody who would like to run RGB node in their home server, or wallet developer, or experts looking into how RGB actually work, while the libraries, they are only for those who would like to play the standards themselves and dig deeply. Three types of libraries. The one set of libraries are related to what we name Internet2, and it's just a generalized Lightning peer-to-peer networking, generalized to be used in all other situations. And it also provides a lot of primitives for building software architecture in a very censorship and decentralized way with the microservices. And this is the library and framework we are using for building all the nodes and all the standards that we have. The second set of libraries is LNPBP libraries, which are written in pure Rust and with a C and WASM foreign function interface. We already have C foreign function interface, and we're planning to add WASM. And these libraries, the libraries we were discussing on the previous slides, which is LNPBP core library, RGB core library, LNP library, and Bitcoin descriptor wallet library. And the third category is platform-specific class libraries for different languages, which are part of RGB SDK. And when you integrate with RGB SDK, you don't need to dig into them. But if you would like to modify the way you need to integrate the functionality or improve it, you will need to dig into those libraries. Another thing I would like to mention is the fact that there are two libraries which require a careful peer review, and they are always, you can't get too much peer review, so we are always welcome and ask for making sure that everything works as expected and checking the code, don't trust, verify. And these two specific parts are, first of all, LNPBP core library, all of it. It's not much now, it's just a few thousand lines of code today, after all the refactoring and removal of components. And the reason it is important, because this LNPBP core library contains Bitcoin commitments and single-use seals code, which is critical for preventing double spending of the RGB transactions. And the second library is RGB core library, which is larger, of course, and it contains all the mission-critical code. Most importantly, this code is isolated from the networking part, from multi-threading, so it's a pure data structure and business logic, so it's easy to review. It has very few dependencies, upstream dependencies. It's, well, I wouldn't say totally test covered, but pretty much well test covered. Has a documentation inside the code. Every part that is related to standards or to anything that can cause a loss of funds or security issue is documented with a plenty of codes or plenty of comments, so it should be really easy to review. This RGB core library contains 4 mission-critical things. First of all, everything related to zero-knowledge, bulletproof Pedersen commitment, so this may contain bugs causing inflation and should be checked against that. Schema validation, making sure that the actual state transaction and evolution of client validated data follows the schema rules and restrictions. State transition graph validation, so making sure that all the states are properly linked and they compose a single history. And finally, it's several machines validating state evolution, making sure that the actual change of states happens according to all of the rules. So these all parts are interrelated, and they are all part of RGB core library. The next thing, I have a schematic representation of how the libraries and repositories are structured. Basically, what we are doing today, and what I would also like to ask a community opinion for, is that because of the amount of the repositories we have, we decided to move topic-specific repositories into separate organizations, GitHub organizations that we had. We already had RGB org on GitHub, so we plan to move all RGB-related repositories into there. We created Internet2 org on GitHub and move everything that is not directly Bitcoin and Lightning Network related to there. So still Internet2 is based on Lightning Network protocol, but not the payment part, not the Bitcoin not anything related to payments, but just networking and cryptography. So we separated that into a separate organization. And the main organization, which is LNPBP, will contain the rest of the code, which includes the LNP node, BP node, and all standards, which are not specific to RGB. And on this scheme, I will use the color representation to show in which specific GitHub organization the specific repository resides. Also, on the scheme, I will show the 3 categories. First is a Rust CRATES, which is basically a part of the repository. These CRATES are organized into repositories, and some of these repositories allow you to build a product, such as the node. So the scheme is organized into layers, and the first bottom layer is actually data primitives. There is a set of primitives related to Bitcoin, pure Bitcoin, and actually I believe that all of this will soon become a part of external libraries, part of Rust Bitcoin libraries. So these Rust Bitcoin libraries that are there today are shown in gray color, and orange color is actually those CRATES and repository that is hosted by LNPBP standards organization on GitHub. The second set is LNPBP core library repository that contains 3 libraries related to client-side validation, strict encode, and the rest of LNPBP standards. So we have 3 CRATES there, and they are based on an amplifier library that extends Rust functions, and it's more generic than anything related to LNPBP actually, and hopefully it will also move to Rust Bitcoin at some point. And the third set is the set related to the networking, this Internet2 repository, and it contains 2 libraries. The Internet2 addresses library, which allows you to use Tor addresses alongside IP addresses without the need to integrate zero message queue or anything like that. And there is Internet2 that actually does the networking on top of that. It's important to know that these specific libraries, they link with Tor and zero message queue and WebSocket dependencies, so they require more compilation conditions, and sometimes when you use them, it will be much harder to compile the project or make sure that it runs on mobile or anywhere else, because you are dealing with compiling C code, external dependencies, and so on. The second layer is the layer of business logic, which is implemented on top of that. And for the Internet2 repository, we have another library inside it called microservices, which help you with the thread and process and RPC APIs management. On top of LNPBP core library and Bitcoin libraries, we have RGB core library implementing the core of RGB. And this library will also contain a specific, this repository will also contain libraries for fungible assets, non-fungible assets, and identity, named after the standards RGB 20, 21, and 22. The next is LNP core library, which will be composed of LNP P2P library for all Lightning Network messages, which nodes exchange with each other, and LNP for the overall business logic of Lightning Network channels. And on top of those, there will be use case specific libraries. Today it is a payments library for normal Lightning channels, peer-to-peer, direct funded, direct two-party channels. And later we will be adding libraries for other cases like channel factories, libraries related for support of Bifrost protocol, watchtowers, and so on and so forth. They are not there yet, that's why they are grayed out. On top of that, there will be an invoicing library for universal invoices that are able to work with Bitcoin, RGB, and Lightning. And on top of that, we actually have the nodes implementation with SDKs. So that's the layerization of the libraries and repositories. And We will publish this presentation, so those developers looking into internals, they will have a guidance how to find specific repository in which organization, which libraries are there, and so on. The difference between the repository and the CRATEL or the library, and why we structure it that way, is that repositories are more about code contribution and management of the review and merge policy, and that's why repository may contain multiple related packages or libraries or CRATES, which are language-specific code, which may be reused multiple times and has some versioning for it. Of course, each library may produce multiple artifacts, which are binary, different forms of compiled library for different platforms and architectures. And separate to this, there is a concept of product, like a node, which is sometimes represented by a single repository or may be composed of multiple repositories or libraries. And I have this schema that defines the difference between these types on the license type, versioning, use case, and so on. So once again, if you would like to understand better the structuring of the repositories and libraries, you are welcome to analyze this slide and propose your comments. The final part of my presentation is how you can use LNPBP and RGB from outside the Rust ecosystem. So it's basically an SDK-related structuring. And here on this scheme, I will show in orange Rust libraries, in green C libraries, and external dependencies will be great. So we have LNPBP core library. On top of it, we have RGB Rust library, the core RGB library. And we will have an lib-RGB with the C bindings to this library. It is not the same as a RGB node, because RGB node uses RGB core library to wrap it into a process and daemons and threads, do storage, do networking, and on top of RGB node, this RGB node, additionally to our core RGB, actually requires this microservices and internet library for doing process management. And on top of that, we have a lib-RGB node. So the difference between lib-RGB and lib-RGB node is that with the lib-RGB node, you can connect external RGB node, or you can run an embedded RGB node. And you have all of the RGB functionality available. You're able to validate consignments, you're able to store them, you're able to produce payments. While with a lib-RGB, you just have a set of RGB primitives. You may do an invoice, you may understand the data coming from a consignment, but you wouldn't be able to manage storage or to do the full validation of the data. So mobile developers today and, well, wallet developers and the changes today and tomorrow, they will be using lib-RGB node library. And on top of that library, we are doing this, first of all, foreign function interfaces, which allows you to export lower level function from the C library into a language-specific bindings. And above them, we have a class libraries, which wraps that into a simple and object-oriented code. So we have that for Java, Python, Swift, and JavaScript. We plan to have a Go version. And JavaScript today is made with a NPM module. However, we plan to add also a WASM-based version of JavaScript, which is planned for later. So here I grayed out the components which are not in the RGB SDK today, and will be added later with future versions. The rest, which is not grayed out, is actually what composes RGB SDK today. The same structure will be used for doing LNP SDK. So basically, it's exactly the same as with RGB. Today, we have much less there, and the work in progress on implementing the language-specific bindings and class libraries. At the end of the presentation, I have 2 slides which I'd like to discuss with you. The one is related how LNP node and RGB node can be used with mobiles. And this is a basically design that we came to during the course of our integration discussions and work with Bitfinex, and from our own experience in developing mobile wallets. Today, as you know, well, the main problem, as I said, is that with the Lightning Network, you need to be online in order to accept the payment. If you would like to build a non-custodial mobile wallet, that actually means that mobile wouldn't be able to accept payments when you're not running the mobile application, and that's a big issue. The industry haven't yet developed a solution, efficient solution for that. Most of solutions, they are in the middle ground of being semi-custodial or custodial, or not being able to accept the payment when the mobile application is offline. Pretty much the same situation applies to RGB node. It's a bit different because in RGB you don't need to produce signatures for accepting the payment, and the payment will pass through, but you wouldn't know about that. So if you was offline, you wouldn't receive the client validated data, you wouldn't receive the consignment, and you wouldn't be able to use these funds after. So you still have to be online or rely on some external infrastructure to store this data and being able to request them later. The overall idea with RGB is that we will have a Bifrost protocol, which allow you to accept the payments on external nodes. They will be kept encrypted, so the privacy is protected there. So wallet developers, for instance, would be able to provide a Bifrost node for their wallet, default node, and users also will be able to select other Bifrost nodes. But before Bifrost is there, we also would like to have some solution. The solution that is proposed here consists of two parts. First of all, it uses all the universal invoices, which we were discussing, specifically the function of universal invoices where you can create a multiple beneficiaries. And the second, it uses the ability of LNP and RGB nodes to be embedded inside mobile application. So the full node can be contained within the application. And the concept is the following. The mobile wallet contains LNP node and RGB node, full validating nodes. These nodes connects to external Electrum server for doing the validation against the on-chain data, and later this Electrum server connection will be replaced with BP node connection. So we don't use neutrino or anything like that. Here we need to make sure that if users would like to don't trust and just verify everything, they would need to set up the Electrum server, which already done by the most of the users, or later they will have an option of running BP node at home or in cloud. This will allow, like when we have just Lightning node and RGB node inside our mobile application, you will be able to accept payments only when you are online. So you are not solving this problem. So the solution, the proposed solution is that there will be an option, two options. The first option is that a wallet company will be able to run a Lightning Network node, LNP node, and this node will be structured in such a way that if the user agrees, actually wallet company will be a custodial for those payments, for those incoming payments, which happens when the user is offline. And we will utilize the multiple beneficiary feature of universal invoices. So when the mobile wallet will be creating an invoice, it will add two beneficiaries. The first beneficiary will be a mobile Lightning node embedded in this wallet. And the second beneficiary will be a wallet company Lightning node, which will be used by a payer if the first payment to the mobile node fails because mobile is offline. So basically, you cover the case when you are able to accept payment when you use the application. And if you are not using the application, the payments still wouldn't be lost. It will be custodial by the wallet company, and the payment will be settled after you will become online as a separate Lightning payment from the wallet directly to wallet company directly to your mobile wallet. If you don't like anything custodial at all and don't trust those satoshis to be stored for you by the wallet developer, you will have an option of setting your own Lightning node and RGB node at home on your server, on your home device, or in the cloud with a private dedicated server or anything that you would like. And when you will have this Lightning node on your own Lightning node, you will do a channel with it from mobile application. And again, you will set two destinations, two beneficiaries, mobile application and your own private Lightning node. And the situation is even better. So if you're offline, the payment will go to your node. If you're online, the payment will go directly to your mobile wallet. So you can have a complete non-custodial setup with a full Lightning node on mobile. Later, we will add to this equation a Bifrost infrastructure, which will provide you a non-custodial way of handling RGB payments, even if you don't have a personal RGB node outside of mobile phone.